I appreciate this opportunity, and it's somewhat unique, and I do hope that everybody's got their COVID-19 nap taken after they've had lunch. Now you're ready to go, so you have a chance to see what goes through. We all understand that since we started farming in the central U.S. that we have been in the land degradation process. This picture was taken in north central Iowa on the Des Moines lobe, taken in the spring. Obviously, it's been wet. But what I'd like you to notice is the different shades of color on these soils. We see the dark area. You know, Iowa is known for its thick, dark, rich, organic matter-laden soils. But and so I ask you, what color is a thick, dark, laden, organic matter-laden soil? And well, it's black. Why do we see the light color patches in these photos? Those are areas in which the original 12 to 16 inches of this dark topsoil existed. It's not there anymore. Soil erosion is our #1 land degradation process, and it's been active and causing that phenomenon that you see in those pictures to occur. So you might ask, well, how much erosion has been occurring? Well, I can't go back with the current technologies to see what happened in the 1900s, but we do have an idea of what's happened recently. This is a daily erosion project, annual estimate of soil erosion spatially across the state of Iowa. These numbers are average for the time period January 1, 2008 through 2016. And the color codes on the right indicate numbers that range from 0, the white, to the very dark, which is over 40 tons per acre per year. And we see that there are vast areas, large areas, in which we're eroding soil at rates beyond the top. Well, what is the tolerable soil erosion rate? Now, you may have answered that in your head. Some of you may not know, but typically that rate is 5 tons per acre per year. On average, the state of Iowa during that time period, hill slope, sheet and rill soil erosion losses were about 5.6 to 5.7 tons per acre per year, which is above the tolerable rate. And we're going to talk a little bit later about how fast soil renews itself. So the question is, so what? What's the big deal? This is a plot of corn yield on the vertical axis versus the acre horizon depth, that black top layer that we talk about, that shows the corn yield response to change in that topsoil depth. Now, this is information collected on the lobe near Boone, Iowa. So what happens as we go left along that horizontal axis to the yields? They fall. These are field measured yields. So what do you suppose the topsoil or the yield levels were in those fields that we looked at? So, but let's talk a little bit about soil regeneration rates. Without humans having an impact, our best science indicates that soils are regenerating at a rate of about 1/2 ton of soil per acre per year. And what did we see in that previous graphic about soil loss rates? Statewide, we are over 10 times our soil regeneration rates. Can we speed up the process? And that's what we're going to talk about today. And if we can't speed the process, are there other ways to improve the performance which would be similar to soil regeneration? Can we help ourselves? My dad always reminded me, excuse me, he said, whenever you're going to pick a fight, there's 2 questions you have to answer yes, or you're ultimately going to be a loser. So this is a fight in terms of renewing soil. The first question he always asked, or told me to ask myself, is the fight worth fighting? Well, I'm going to say that yes, this fight is worth fighting. The next one he said, if you're going to pick a fight, says you got to know whether or not you can win. Well, let's see if we can win this one. You can drive down the road, any place in Iowa or Midwestern states, and you can see these bare areas, these areas that are light colored. What do you suppose the yield levels are in those areas? If you go back to this original graphic that we looked at, if you start with a topsoil depth of let's say 10 inches, and on those fields you were looking at yields of, 135, 140 bushels per acre. You go to the red line, the long red line, when we had topsoil depths of about 6 to 7 inches, we were at 120 some. Get down to 3 or 4 inches, about 3 inches, 2.5, we're down to less than 100. What would we have if we was zero? Those light-colored arrows, or light-colored areas we were looking at in those graphics are zero. What does that do to crop yield? Major negative impact. So when we talk about soil health, what is the primary, the number one item that we talk about in terms of whether or not a soil is healthy or not? We typically talk about soil organic matter content. I'm going to make an argument that soil organic matter, if we can increase soil organic matter, we are not regenerating the soil as it was before, but we're improving the way that it performs. And I like to use the example of a star basketball player that sprains an ankle. His ankle sprains so bad he can't play anymore, she can't play anymore, but you take him out, tape up that ankle, and you put him back in the ball game. The guy can still shoot, she can shoot, they can run, they can do whatever. They're not as good as they were before the injury, but you can improve it to the point that they are functional. And that's what I think we can do with soil organic matter content. So the next about 3 or 4 slides, are not too exciting. In fact, as they may even put a cup of coffee to sleep. But I think they're pretty important as we try to understand whether or not we can fix this, or whether we can't, and if we can, how long is it going to take? So there's a few facts in here that are seemingly important to know as we try to figure this out. Number one, we're going to talk about changing the organic matter content in 1 acre furrow slice. 1 acre furrow slice is actually about 6.7 inches, but for easy calculations, and we're just trying to put a decimal point on this. Let's assume it's 6 inches thick. How thick was that original topsoil that I'd mentioned before we started farming? We had between 12 to 14, 16 inches everywhere. So we're talking about a fraction of that. But for repair purposes, I think this is moving good. An acre furrow slice weighs about 2 million pounds. What is a good soil organic matter content in a highly productive soil? We typically like to see 4 to 6%. So if we start from zero, or no matter where we start from, if we're going to increase the soil organic matter content by 1% of that 6-inch layer, we need to add to that 6-inch layer 20,000 pounds of resistant organic matter, material that won't decompose. That's the material that makes our soils black and rich and productive. Can we do that? So how are we going to add that organic matter? Well, there are multiple ways. You can add it by cover crop, SOM. In the future graphic stands for soil organic matter. You can add them with cover crops. Barnyard manure. You could change rotations. You could put in, and rather than row crop or in addition to row crop, you could add perennials. You could do pasture. There are multiple ways that you can address this. For today, to give us a calculation, an estimate of how much and how long, we're going to look at 2 sources of organic matter, that of the corn plant and that of a cover crop plant. If we add organic material from both of those, how long will it take to bring a soil organic matter content up to where we want? First and foremost, the majority of the soil organic matter that we find in Iowa soils or any soils comes from plant roots, upwards of 90%. All the dry biomass that you see, all the biomass above ground, it's nice and it does contribute some. But by and large, the cream of the crop comes from the root material. So how much dry matter do we get? And so ultimately, how much root matter do we have for a 200 bushel corn crop? 200 bushels of corn weighs about 10,000 pounds. So somebody's in the audience saying, whoa, that's not right. A bushel of corn weighs 56 point something. but that's at 16% water. Remove the water and you're down actually to about 48 pounds. So for easy calculation, we're going to assume that a bushel of corn weighs 1,000 pounds. Now that's important because we ultimately need to get to the root weight, so we have to also ask how much does the biomass weigh. Well, a corn crop, the harvest index is about 0.5, so that means the residue also weighs about 10,000 pounds. So we're looking at a total of 10,000 pounds. Now the reason I do that is that to get to the root weight, we have something called a root to shoot ratio. What fraction of the total crop biomass grows underground? And remember, we're asking this question because soil organic matter is dominantly composed of organic matter that comes from the root materials. So with a corn root to root ratio of about 0.2 to 0.4, now this depends upon who you talk to, how deep you're making the measurements. For easy calculations, we're going to assume that it's 0.3. That means that about 6,000 pounds of plant material grows underground for a corn crop in which we're getting 200 bushels per acre. So there's 6,000 pounds we can add to this 2 million pound acre furrow slice to start bringing our soil organic matter content up. Well, but wait a minute. That material is really it's not too resilient to decomposition. In fact, in the first year, we're going to lose about 60% of it. That 60% of material we lose is not available to coat soil particles to raise soil organic matter. So that brings us down. A year later, we have about 3,600 pounds of organic matter remaining, of loss. 3,600 pounds of loss says that we have about 2,400 pounds of root organic material remaining for the soil to increase the soil organic matter in the subsequent year. Okay, that's a break so you don't have to think real hard, just for a second. It also makes me feel good too. But I'm biased and selfish too. Okay, so back to business. So what about cover crop roots? How much do cover crops contribute? Data from Rafael Martinez, Renee Dietzel, Matt Helmers, Matt Liebman, and Zatorius Sarkintoulis doing work here in central Iowa. They've estimated rye, cover crop, root biomass over about 4 or 5 different years. The root biomass was highly variable, as you imagine, because the success in seeding, cover crops, fall application varies an immense amount based on weather. Across those years, they had numbers ranging from about 400 or 600 pounds per acre to close to 3,000 pounds per acre. But on average, across those years, it was about 1,300 pounds of root material in the top 12 inches of soil that they sampled. Okay, now remember, we're going to lose 60% of that for the first year. So that leaves us 520 pounds remaining in the year following sampling. So when we add the resistant cord root material that was left over after the initial year of decomposition to that same type of material, the resistant cover crop root material, we are approaching 3,000 pounds of resistant soil organic matter coming from the root material, which is the dominant source of soil organic matter, each year. 3,000 pounds per acre per year. How many pounds did we say we need to raise the soil organic matter content 1%? That was 20,000 pounds. So we need 20,000 pounds of soil organic matter to raise the organic matter content 1% in 6 inches. So that says if we're basing our success in terms of trying to regenerate soil, it's going to require 6 to 7 years to raise the soil organic matter content 1% in that top 6 inches. Now, you understand this assumes there is none of the above ground biomass contributing to soil organic matter, and that is not true. There is some that contributes, but this is a biggie. It also assumes that there's no soil erosion loss of soil organic matter. You remember those pictures that we saw of the landscape? Where do most of those problems, not most, all of them exist? They're on the hill slopes. We will never regenerate soil health if we don't stop soil erosion. So we have to use management processes, management choices, to not only add soil organic matter, but to control soil erosion at the same time. And fortunately, the best practices for adding soil organic matter are also good practices for controlling soil erosion losses. Also need to understand, we are not including root exudates as part of the contribution to the soil organic matter source. And some studies indicate that the root exudates, the amount of material that the cells that the roots slough as they grow, some liquids they give off, the weight of carbon in that is nearly as much as the root mass itself. We could use other forage crops, other crops such as forage crops that have a greater capacity to add soil organic matter to the soil. Tillage and sampling depth have a huge interaction. I've heard farmers say that they've increased the soil organic matter 2 or 3% in 1 or 2 years, and I don't laugh. I understand. You know, we can do the same thing. It depends on the sampling depth. Remember, we are diluting the soil organic matter. We're talking about across 6 inches, 2 million pounds. The most important layer relative to soil erosion, water infiltration, aeration is that surface 1 or 2 inches. So if through, for example, no-till and cover crops, we can increase the soil organic matter content, and you can do the math to work this out, by 1 or 2% in 3 or 4 years, so be it, and it's a great plus. So should we fight the battle of soil renewal? I think the answer is absolutely yes. Is the fight that we can win? Yes, it is. It takes a little bit of management skill and commitment. Every time we add biology to a system, we add a little bit more management skill necessary to make that system work. And it takes dedication. So, finally, you know, most fishermen refuse to tell you where they catch what they do, whereas my buddy says, I'll tell you where I caught that fish, but I'm going to have to kill you. Well, I'm not going to do that. I'm going to show you how generous I am. I'm going to show you exactly where I caught these fish, so you can go to that exact place the next time you grab your fishing pole. Thank you very much. You've seen it all. Happy to try to answer any questions.